Today I will talk about the code that I have written to make the TurtleSim to draw a square. So this is the publisher to publish the angular velocity and also the linear velocity to the TurtleSim, and this one, the subscriber, is used to get the information from the TurtleSim window to get the information about the position and also orientation of the TurtleSim. So the rate of this code is 30 Hz, and so first I define a target degree so that the TurtleSim can be turned from the current angle into this angle, which is 90 degrees, which means that it faces upward. And this is the change of the angle after complete the linear direction. And this is the size or the length of the square. And I define a state here. So state 1 means that it is undergo the turning motion, and state equal to 2 means that it is undergo the linear motion. And here I define the D arrow, which means that if the difference between the current angle or current distance is equal to the target, the difference between the target and the current is less than this value, then it will proceed to another step, which is either the linear motion or the angular motion. And here is the gain for the angular velocity, and this is the gain for the linear velocity. So if there is no message received from the TurtleSim, then it will run this code. It will keep on running and running. And if there is any message received, then it will proceed to this code, and the x position is encoded in x, the y is in y, and the theta is the angle of the turtle in the TurtleSim. So after this, it will proceed to this code. First, I define the state equal to 1, so means that it will start with turning. So if the target angle, if the arrow between the target angle and the current angle, I define the arrow here. The arrow is the target angle minus the current angle. So this is a normalization of the angle. And if the current angle so the angular velocity is proportional to the arrow, and if the arrow is less than B arrow, which means that it's less than 0.0001, then it will the position of x and y will be encoded, and the state will become 2, which means that it will start the linear motion. So it will proceed to this code, and first I define the distance travel. Since I have the initial position after the turning, so I have the initial position here, and I also have the current position here, the x and y, so I can actually calculate the distance travel by the turtle. And the arrow is defined as the target distance, which is 4 in this case, which is 4, and minus the distance travel. So this is the arrow, and the linear velocity is proportional to the arrow and the angular velocity, because it is linear motion, so the angular velocity is equal to 0. So if the arrow is less than the D arrow, which is 0.0001, then the target angle will be plus the D theta. So initially it is 90 degree, and plus the 90 degree again, so that it will become 180 degree. So since the target angle, the current angles is no more, the target is not the same as the target angle, so it will proceed to the state 1 here. because when the arrow is less than the D arrow, the state will become 1, so it will start turning again. And this will be this code will be loop, is a loop, so it will run and run and run again. And finally, the velocity, the angular velocity and also the linear velocity will be sent to the TurtleSim. So if I run this code, you can see the TurtleSim. Turtle is actually running. It's actually drawing a square. So I will end this video today. Thank you.